Assalamualaikum warahmatullahi ta'ala wabarakatuh and a very good morning. Welcome to the lecture 11 for SK0014. This topic, you will learn about the electron configuration and atomic orbital. This is the chapter outlines for the topic. Includes to write down the electron configuration, to draw the orbital diagram, to define the Aufbau principle, Hund's rules and Paulis exclusion principle, and also about the inner, outer, and valence electrons. The learning outcomes at the end of the topics, students should be able to write down the electron configuration, to draw the orbital diagram, to define the Aufbau principle, Hund's rule, and Paulis exclusion principle, and also students should be able to differentiate between the types of the electrons and also to relate the quantum numbers with the orbital diagram. Before I further explain about the topic, let's do the revision. From the previous topic, you already know that the quantum numbers can be indicated based on the four principles. The first principle is about the principal quantum number with the symbol n. N indicates the energy level of the electrons being placed, and the value of n is the positive integers start from 1, 2, 3, and so on. The second one about the angular momentum quantum number with the symbol L. L depends on the value of n, where the value of L is the integers from 0 to n minus 1. And then the third one about the magnetic quantum number with the symbol ML. The ML depends on the value of L, where the value of ML is the integers from negative L to 0 to positive L. The last one about the spin quantum number with the symbol MS. The spin quantum number indicates that in orbital, the electron can be positive half and negative half. Positive half and negative half. The angular momentum quantum number L also indicates the type of orbital. When the L is 0, it indicates the s orbital. And when the L is 1, it indicates the p orbital. When the L is 0, it indicates d orbital. And when the L is 3, it indicates the f orbital. And then, as I said from the previous slide, the angular momentum quantum number L also indicates the value of magnetic quantum number ML, where the ML can be defined from negative L to 0 to positive L. When L is 0, ML also 0. When the L is 1, it means that the magnetic quantum number ML is from negative 1, 0, positive 1. When the L is 2, it starts from negative 2, negative 1, 0, positive 1, and positive 2, and so on. The quantum numbers also indicates the shell, subshell, and orbital, where the principal quantum number indicates the shell, and angular momentum number indicates the subshell, and the magnetic quantum number indicates the orbital. And these quantum numbers are like an address, where we can indicate where the electron lives and what the address of the electron. Okay, first we look into the n. As I said, n indicates the shell. Either n is equal to 1, 2, 3, and so on. Next, from the value of n, we can detect the value of L, where the value of L is equal to from integer from 0, 1, 2, and so on until n minus 1. For example, when n is 1, we can detect that L is 0. And when n is 2, we can detect that L is 0 and 1. And n is 3, we have L 0, 1, and 2. And then from the angular momentum quantum number also, we can detect the types of orbital. For example, when n is 1, the L is 0. 0 indicates the s orbital. And then for when n is 2, we have L, 0 and 1. So which means in this energy level, we have S and P orbital. While in the energy level of N3 is equal to 3, we have S, P, D orbitals. And then also the angular momentum quantum number known as the subshell. So until now, you know that we have the shell, which is N, the subshell, which is L. Next, from the subshell, we can detect the orbital from the value of ml, which is the magnetic quantum number. The magnetic quantum number depends on the value of L, where the value of ml is from the negative L to 0 to positive L. For example, when L is 0, the ml is 0. And then for the L is 0 and 1, so which means we have different types of ml. For L is 0, ml is 0. While for when L is 1, so which means we have ml is equal to negative 1, 0 and positive 1. While for the L 0, 1, 2 at N3, which means we have a various of the ml values. So when L is 0, we have ml is equal to 0, L is equal to 1, ml is equal to negative 1, 0 and positive 1. And then when the L is 2, so which means we have ml is negative 2, negative 1, 0, plus 1 and plus 2. So which means from the value of the ml, it indicates how many orbital in the subshell. How many orbital in the subshell. So which means for the L0, for the subshell 0, the ml is 0. So which means we have 1 orbital in the L0. For the L1, we have ml 1, 2, 3. So which means for the L1, we have 3 orbitals. While for the L2, ml is we have 1, 2, 3, 4, 5. So which means L2 we have 5 orbitals. So this is how to detect the shell, subshell and the orbitals. Dan kita boleh lihat daripada example ni, kita boleh nampak how to detect the shell, subshell and orbital. So for example here, when the shell n is equal to 2, dalam shell ni kita ada dua subshell, iaitu 0 dengan 1. Okay, 0 and 1. And then from the subshell ni kita boleh detect what is the type of orbital dan present dekat shell ni, which is 0 is equal to the S orbital and 1 is equal to the P orbital. Then from the subshell, kita boleh determine how many orbitals they have. For example, when L is 0, ml is 0. And then when L is 1, so which means we have the orbital negative 1, 0 and positive 1. So each of these numbers of ml represent the orbital. So which mean pada dekat sini when L is 0, kita cuma ada satu orbital sahaja. While dekat L is equal to 1, kita ada 1, 2, 3 orbital. Okay, 3 orbital. And then you must remember that one orbital can only occupy maximum 2 electrons. Okay, can only occupy maximum 2 electrons. So which mean for L is 0, kita cuma boleh isi sebanyak 2 elektron sahaja. Tetapi untuk L is equal to 1, since dia ada 3 orbital, kita boleh isi 6 elektron paling maksimum. So this is how to detect how many elektron yang kita boleh isi dalam orbital tersebut. Okay. The last part on the revision about the MS, the spin quantum number. For the spin quantum number, it just indicates the orientation of electron, either positive half or negative half in the one orbital. So which means in one orbital, the electron can be placed either positive half or negative half. Okay, positive half or negative 1. negative half. So you need to remember, one orbital can fit 2 electrons only. Okay, the maximum electron can fit in one orbital is 2 electrons. Itu yang penting Alright. Baru kita masuk for the first section, which is how to write down the electron configuration and draw orbital diagram. So before that, kita tengok dulu dekat this one. Okay, I think you already familiar about this symbol. Indicates the element, atomic number and mass number. The atomic number is equal to the number of proton and number of electrons, while for the mass number can get from the combination of number of neutron plus atomic number. So based on for the electron configuration, the things that really important is about the atomic number, because the atomic number can give you the number of electron. Okay, number of electron, and then from the number of electron you can write down or draw the orbital diagram. Based on your SPM level, I think kamu kena ajar cara untuk draw ataupun tulis the orbital diagram or electron configuration based on the number notation 28, 18, 32. But based on your level right now, ini tidak digunakan lagi. Okay, so untuk electron configuration kita boleh lukis berdasarkan the shorthand. Okay, the shorthand notation. Okay, di mana dekat sini kamu boleh buat secara cara macam inilah. Kena ada indicates the energy level, the subshell, and then the number of electron dalam subshell tersebut. Okay, kita kena indicates dia punya the number of indicates the energy level, which is the shell, and then dia punya subshell, and then number of electron yang berada dekat subshell tersebut. Okay, itu untuk electron configuration. For the orbital diagrams, kita boleh draw the orbital diagrams either dalam bentuk kotak, circles, or just draw in line. Okay, yang penting dia ada kotak, dalam bentuk circles, or dalam line. As I said, satu orbital cuma boleh isi 2 elektron sahaja, di mana 2 elektron itu either dia boleh positive half or negative half. Dia tidak boleh positive half, tidak boleh negative half and negative half. Next, we move to the another section, which is the 3 rules to build up the electron configurations and orbital diagrams. So which mean we need to follow these 3 rules to first to write down the electron configuration, second to draw the orbital diagram. The 3 rules are Aufbau principle, Hund's rules, and Paulis exclusion principles. First, we move to the Aufbau principle. For the Aufbau principle, it mentioned that the electrons need to enter the orbitals in order of ascending energy. Okay, you need to enter the orbitals in order of ascending energy. How we need to arrange or to determine the ascending energy of orbital? We can determine the ascending energy of orbital by doing like this. Okay, bila kita tengok dekat sini, kita ada energy level which is N and subshell is L. So if you can see here, the SPDF refer to the subshell, where S orbital means that L is equal to 0, P orbital is 1, D orbital L is 2, and F orbital is 3, F, G, H, and another lah. Okay, for energy level, and when N is equal to 1, so which mean in N equals to 1, it has only one orbital, which is S orbital. When N is equal to 2, they have possessed 2 orbital, to S and to P. And then for 3S, for N is equal to 3, they have 3 orbitals, 3S, 3P, and 3D. So first of all, if you want to start to write down the ascending order of orbital, first we move like this one. First is 1s. The second one is 2s. The third one is 2p, and then 3s. Here 2p and 3s. The next one is 3p and 4s, and then another sequence is 3d, 4p and 5s, and so on. This is how to write down the ascending order of orbital. So if you want to enter the electron into the orbital, you need to enter into this sequence lah. 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p and 5s. This is how to arrange the ascending order of orbital. This is another additional information in explaining the ascending order in which atomic orbitals are filled. Now we move to the example. Before we do the example, just a simple revision. Okay, for s orbital, dia boleh isi hanya 2 elektron sahaja, paling maksimum. For b orbital, 6 electrons, and d orbital 10 electrons. Okay, 10 electron. So first we go to the first example, which is carbon. Let's say kita ada carbon and then Z is equal to 6. When Z is equal to 6, it means that this is indicate the number of electron also. So by doing the ascending energy of orbital, kita start with the 1s, di mana s orbital boleh isi 2 elektron sahaja. And then bila kita tengok 6 dengan 2, tinggal 4 elektron yang tinggal. So for the next orbital is 2s, which is we can also fill up with 2 electron. Then we already use 4 electrons. Now we have 2 electrons remaining, and then for the 2 remaining electron kita masukkan for the next orbital, which is 2p, which is we just type 2 here, write down 2. So this is how to write down the electron configuration for carbon, 6 electron, which fill up 1s, 2s and 2p orbital. Next, another example, what if we use the sodium? Okay, sodium, Z is equal to 11. Okay, Z is equal to 11. So as usual, 1s, 2, okay, 2s2, already consume 4 electrons. Now we left, just left 2, 11 minus 4, 7. Okay, so 2p6, and then the last one is 3s1. So which means we already use all the electron. 2, 2, 6, 10 plus 1, 11. So this is the electron configuration for sodium. And then we move to the next example. Okay, for the next example is what if we use the potassium. Okay, potassium. Okay, Z is equal to 19. Okay, we start with 1s2, 2s2, 2p6, and then another 9 left. We continue 3s2, and then after 3s is 3p, 6. Now we just use 1, 2, 3, 6, 18, and then another 1 electron, which is we include or fill up the 4s. 3p after 3p is 4s, 4s1. So we consume all the electron. 2 to 6, 10, 12, 18 and 19. So this is the electron configuration for potassium. And then another last example. Why don't we try fluorine? Why don't we try fluorine, which is fluorine is 9. Okay, fluorine Z is equal to 9. So 1s2, 2s2, and then we already use 4 electrons. Now remaining 5 electron. So the 5 electron we just fill up the 2p, which is 5. 1 to the 9. Okay, 2 to 5 is 9. So this is how the electron configuration for fluorine can be written out. So this is how to use or to follow the Hund's rule. Alright, why don't you try to write down the electron configuration for this element, which are the calcium and the calcium and Z20 and iron, okay, Fe Z26. Okay, you can try later. Now we move to the second principle to write down and to draw the orbital diagram, which is the Hund's rules. In Hund's rules, it mentioned that orbitals of the same energy must be occupied singly and with the same spin before pairing up of electrons occurs. Okay, so we move terus tengok pada carbon. Okay, you already know how to draw the how to write down the electron configuration of carbon using the Aufbau principles. So 1s2, 2s2 and 2p2. Now how to draw the orbital diagram using the rule Hund's rule. So first of all, as I said, to draw the orbital diagram, either you use the box, the circle or the line. So here I use the box. Okay, so we build up the box for each orbital. 1s with 1 orbital, 2s with 1 orbital, and 2p with 3 orbitals. And then we start to fill up the electron. Okay, fill up the electron. So which means for the 1s we need to fill up the 1s first. So this is the first electron, the second electron. Remember, using the spin quantum number, half positive, half negative. Next, we fill up the 2s orbital, half positive, half negative. And then another remaining electron, we fill up in the 2p orbital, which is in -1 orbital for the first electron. And then the last orbital will fill up the orbital of 0. So if you fill up the orbital like this one, 2p here and then next here, then you are wrong. So based on the Hund's rule, you need to fill up first singly, okay, half positive for each electron, for each orbital, then baru kamu fill up for the negative half. Okay, for example, let's say I just want to fill up all the orbital into p. Okay, orbital into p orbital. So first we just singly first. Okay, next this one. So this is how to draw the full orbital. Okay, full orbital of 2p. Singly first, then we pairing up with the negative half. Okay, next we can do another example, which using the Na first, sodium, Z is equal to 11. So we just based on our example from the previous slide, 1s2 2s2 2p6 and 3s1. Okay, so this is the electron configuration for the sodium. Now we draw the orbital diagram. I just use the line 1s, 2s, 2p and 3s. So we start with fill up the 1s. 1 2 3 4 5 6 7 8 9 10 and 11. So this is how to draw the orbital diagram for the sodium. Next we do the fluorine. Okay, the fluorine, Z is equal to 9, 1s2 2s2 2p 5, same 1s 2s and 2p. Okay, 1s 2s, and for 2p is 5, so 1 2 3 4 and 5. So this is how to draw the orbital diagram for the fluorine. Another example, okay, another example is what is that? Oxygen. Okay, Z is equal to F. Okay, the electron configuration 1s2 2s2 2p4. Okay, then we draw the orbital diagram. We need 1s orbital, 2s orbital and 2p, s 2s and 2p. So we start to fill up the electron in the orbital. So 1s, 2 electron, 2s, 2 electron and 2p, 4 electrons, 1 2 3 and 4. So this is how to draw the orbital diagram using the Hans rule. So I hope you understand about the Hans rule. Next is about the Paulis exclusion principle. For the Paulis exclusion principle, it mentioned that the electrons occupying the same orbital must have the opposite spin. Okay, must have the opposite spin, which means we need to fill up the electron in the orbital half positive and half negative, upward and backward. We cannot draw the orbital like this one. Okay, let's say we have a 3p4. Okay, 1 2 3 and 4. This is wrong. Okay, this is wrong. Okay, the right answer is 3p 1 2 3 and 4. So which means we have half positive and half negative of electron, the spins of electron. Okay, for example like this one, okay, cannot. And this is the right method to fill up the electron, one upward, one downward. Okay, so you can do the exercise, we can do the exercise together. Right, so identify which part and rules is violated for the first example here. So if you can see here, let's say this is 1s. Okay, for the 1s is correct, 2s is correct and 2p. So if you can see here, if following the Hans rule, okay, following the Hans rule, we need to singly fill up first with the same orientation, and then baru kita pairing up with the different orientation. So which mean for the first example, it violated the Hans rule. Okay, the Hans rule. And then for the second example, 1s is correct, 2s also correct, and 3s and 2p. If you can see in 2p orbital, this also violated the Hans rule. Because of what? Because we need to what? We need to fill up singly first. Okay, we need to fill up singly electron first with the same orientation. So which mean we need to fill up like this one. Okay, so also the second, it been violated. The Hans rule is violated. And the third one, for the 2s, since it has same orientation, last and last, so it while disobey the Paulis exclusion principle, which mean for the real answer is you need to make it different orientation, upward and back, downward. So this is how to draw the electron configuration. Okay.